Hello, beautiful people. Today we have a motion problem. So we have we have an astronaut that throws a little ball of mass m, okay? But we neglect the height of the astronaut, so we just pretend. I got a message that this is the x-axis and this is the y-axis. I mean, we pretend that the ball, rock, or whatever is cast. That's an English word, right? Yeah, from the ground. And so you can draw it pretty. Foop. No. Foop. Okay, so we have the x-axis, we have the y. No, we have the x-axis, we have the y-axis. We have these. We have these, which becomes length, and which is gonna be what we're looking for. I need to find another way to do these videos. Actually, no, another way, but yeah. This is time 0, the initial. This is the final time. Yes, and we have a mass flying. This is the velocity, and this is a known angle, theta, which is 30 degrees. Now, what do we start with? We start with writing the position equations. Is that what they're called? I guess. I just know them. I don't remember. I'm studying in Swedish, but I don't know Swedish, so I don't know either the names in English nor in Swedish. Just the process, okay? Just the process. So we have V0 t here, and we have y t, and we have the height, which is in this case is gonna be 0 because we depart from the ground, but I'll write it right now anyways. Still V0 t plus 1 second. Oh yeah, and we have a force of gravity g because we're in another planet, let's say, and since it's going down, still always negative, so I can just write minus g. This is like a 9. Foop. T squared. Okay. Foop. We know that the initial position. We start with the x. I always start with the foop, and the velocity in the x and in the y are equal to v cos theta and v sin theta. Here we have the zeros. Okay. And then another part is that we know that when at time t, so now we have time 0 here, okay, but at time t we will have that x is L, right? So xt will be L, while y will be 0, because here you're on the ground again. So yt will be equal to 0. Dun, dun, dun. Things get more intense. I wanted to make this like an ASMR video, like, did you know that? Like, you know, some recipe videos. Yeah, that doesn't matter. But like now I'm realizing that it's a bit long. But okay. Now the steps. We have, okay, the process. We will set the two x's equal to each other and the two y's equal to each other. So we will have that L is equal to V0 cos theta t, and 0 is equal to, well, h, which is 0, so not gonna write it, V0 sin theta, still t, minus gt squared over 2. Now we will want to set the big T inside this small t. But what is the big T is the question. Well, we can use a helper formula, or yeah, which is SVT, which fun fact is a Swedish radio too. This is distance, this is velocity, and this is time. And so we can say that time is equal to distance over velocity, which is equal to L over V0 x, or also just this. Okay, and now we can put it in. Okay, and yes, minus, same thing with G. Oh yeah, we did maybe I should show the step. Maybe it wasn't a good cut, but like whoop whoop whoop. Okay, maybe I should write it down. So we have L squared over 2 is 0 cos squared. Okay, and all this is equal to 0. And what do we have? This. I don't know if the transition worked, but we just put this there, and so it's positive now. And now we can cancel a few things out. That was so robot-like. So we cancel this, and then this, and then this, and then this. So we now have that V0 sin theta is equal to GL. Like this is like another different kind of gravity, because the problem said that it can be like whatever. And then 2 V0 cos theta. And now we remember that we're looking for L, because it's a loser. I'm tired. So we will want to isolate it now. So what we're gonna do is gonna be we multiply by this and divide by this, right? And we get to this point. We know that there is a trigonometric identity that says that 2 sin theta cos theta is equal to sin 2 theta. So it becomes this. I will write a bit. V2 squared, because we have to V, and then sin, wait, I just said it and I just forgot. Foop over G is equal to L. Now we know also that theta is equal to 30 degrees. And we also know that thus to theta is equal to 60 degrees. And we know, seeing the unit circle, that when it's 60 degrees, sin is square root of 3 over 2, sin theta. When sin 60 degrees is, yes. So 3 square over 2. No, square root of 3 over 2. It's late. No, it's not that late, but like it's late for me. Okay, so we can write with V0. Foop is equal to 2G, which is equal L. And that is how we solve it. If you understood anything, good job.